So in this video I want to look at experiments that involve two tasks and thinking about some probabilities. So here my experiment is to roll two dice. So two dice are rolled. First task, roll a die. Second task, roll a second die. So altogether we've two rolls of a die. Two dice rolls. Show the sample space in a two-way table. Okay, so two-way table is a nice way to show the sample space. I could do a tree diagram for this, but it would get a bit messy, you know. So I'm going to just draw a two-way table showing all the possible outcomes. So all the possible outcomes look like this. I have one done up already. You don't want to watch me drawing this. So what we have is 1, 1 on the first dice, and then 1 on the second one. 1 on the first, then 2 on the second. 1 on the first, then 3 on the second. 1 on the first, then 4 on the second. 1 on the first, 5 on the second. 1 on the first, 6 on the second. Okay, down here would be 4 on the first die, 3 on the second. Down here, 6 on the first die, 6 on the second. Generally, when we roll a pair of dice, we find a score by adding the numbers on the upward face. Okay? So, 1 on the first die, 1 on the second. That would be an outcome or a score of 2. So if I'm adding the two die scores, well then, my scores would look like this. So 1, 1, well that corresponds with a score of 2. 1, 2 corresponds with a score of 3. 1, 3 corresponds with a score of 4. And the question that's asked here is, what is the most likely total score? What is the most likely total score? What comes up most often? Well, there's only one way I can roll a 2. There are 2 ways I can roll a 3. There are 3 ways I can roll a 4. 4 ways I can roll a 5. There's 6 ways I can roll a 6. There's 7 ways I can roll a 7. The most likely total score is 7. There's only 1, 2, 3, 4, 5 ways I can roll an 8. 4 ways I can roll a 9. 3 ways I can roll a 10. 2 ways I can roll 11. 1 way I can roll a 12. So 7 can be rolled in this way. 6 on the first, 1 on the second, or 5 on the first, 2 on the second, 4 on the first, 3 on the second, 3 on the first die, 4 on the second, 2 on the first die, 5 on the second, or 1 on the first die, 6 on the second. So there are 7 different, there are 6 different ways. 1, 2, 3, 4, 5, 6 that I can roll a 7. Okay? And the probability of rolling a 7 is, remember, the probability of any event is the number of ways the event may occur divided by the total number of possible outcomes. When I roll 2 dice, the total number of possible outcomes here are 36. The number of ways I can roll a 7, 1, 2, 3, 4, 5, 6. There's 6 ways I can roll a 7. So there's a 1 in 6 chance of rolling a 7 when you roll a pair of dice. Okay? Notice there's not 36 different scores. There's 11 different scores. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And not 36 different scores, but there are 36 possible outcomes, because 3 on the first and 4 on the second, that's a different outcome to 4 on the first and 3 on the second. What scores have equal probabilities? Well, the probability of rolling a 2 will be the same as the probability of rolling a 12, because there's only one way to do each of those. And you can see a kind of symmetry here. If I draw a kind of diagonal line up from this corner, there is a kind of symmetry here. 6 can be achieved in 5 ways. 8 can be achieved in 5 ways. 5 can be achieved in 4 ways, as can 9. 3 can be achieved in 2 ways. So the probability of 3 is equal to the probability of 11. And both of those have a probability 2 ways out of 36, or 1 in 18. Probability of 2 or the probability of 12, each of those have probability of 1 in 36. Only one possible outcome, one way that event may occur, divided by 36 possible outcomes. The probability of rolling a 4 is equal to the probability of rolling a 4 can be rolled in 3 ways, as can 10. I'm rolling a 10. And that probability is equal to the number of ways that event may occur is 3, divided by the total number of outcomes, 36. That'll reduce to 1 in 12. So probability of 4 and probability of 10 are both 1/12. The probability of rolling a 5 will equal the probability of rolling a 9, and each of those outcomes can be achieved. 5 can be scored in 1, 2, 3, 4 different ways. So it's 4 out of 36, or 1/9. Okay, and then finally the probability of rolling a 6 will be equal to the probability of rolling an 8. How many ways can I do that? Well, there's 1, 2, 3, 4, 5 ways I can roll a 6. So the event can be achieved in 5 ways out of the total number of possible outcome, 36. Find the probability of a prime. Well, if we look at all the primes, and you highlight all the primes in here, 2 is prime, 3 is prime, 4 is not, 5 is prime, 7 is prime, 8, 9, 10 are not prime, 11 is prime. So there's all my primes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's a 15 out of 36 chance, and that fraction will reduce to 5 and 12. Okay, so anytime we have 2 tasks, we can draw a two-way table. If there are 2 tasks, we can draw a two-way table. Roll a die, toss a coin. You can draw a two-way table. Anytime you have 2 tasks, you can draw a two-way table. You could draw a tree diagram as well, but it would be messy here. There's just too much going on. Okay, so practice 2 tasks